Okay, now we're working on the hyperbola. Look, parabolas, ellipses, and hyperbolas have a lot of similarities. So let's start out with noting that the basics for this is a hyperbola centered at the origin, and the reason I know that is because there's nothing added or subtracted with x squared or y squared. So if you look on page 765, you'll see, let me get to page 765. All right, so this gives us the rundown on hyperbolas. So the equation looks like the equation of an ellipse except for their subtraction. And depending on whether or not our ellipses go across a line that is parallel to the x-axis, as on the left, or a line that's parallel to the I take that back, parallel to the x-axis on the right, and parallel to the y-axis on the left. It just depends on whether or not x squared or y squared is listed first. And when you see that, you can tell which form you're working with. Okay, so getting back to our problem, just graphing the function x squared over 4 minus y squared over 9. We're going to rewrite this in what they call standard form by squaring the denominators. Okay, so that uncovers a couple things. First of all, a and b, a equals 2, b equals 3. And the way we graph these is we start at the origin, we start at the center of the hyperbola, and then we just graph a line, an asymptote line. And so if you look on page 765, the asymptote lines are y equals b over ax, and also y equals negative b over ax. We really only graph the positive when we're graphing our hyperbolas. So for this hyperbola, the asymptote line is going to be 3 over 2x, and the negative asymptote is going to be negative 3 over 2x. Okay, so here's how we're going to graph this hyperbola. Okay, so because our vertices intersect parallel to the x-axis, we're going to pick that far right hyperbola. We're going to put a point at the origin. And now I'm going to graph a line of 3 over 2. So up 3 over 2, and there's the graph of that hyperbola. So just use the slope, leaving from the center of your hyperbola in order to graph it. I'll come back and use that. And we're done with example 1. All right, write equation of the hyperbola in standard form, identify the vertices, the foci, and write the equations of the asymptotes. Okay, so let's start out with x squared over 3 squared minus y squared over 4 squared. So a is always the number underneath the first fraction. So a is 3, b is 4. And by the way, my foci are found pretty much the same way as last time, but c is going to be the square root of a squared plus b squared. So we just add the a and b and take the square root. And we'll need 2 of these, plus or minus 5. So our foci are at plus or minus 5. Okay, so since our hyperbola is going to be intersecting the vertexes on the x-axis on this one, or when it moves around it's going to be parallel to the x-axis, that means that our y is 0. And the same with the foci. So if these 2 points are my vertices, my foci are going to be just inside, but they're on the same axis is the point. Okay, so 0, 0. So the vertices are underneath the x, so that's going to be negative 3, 0, and 3, 0. And same idea with the foci. We're going to get a negative 5, 0, and a 5, 0. Our asymptotes are, again, going to be y equals b over a, x, and also negative. So we get y equals 3 over 4x, and y equals negative 3 over 4x. And we're done with that problem. Okay, I'm going to stop this video. See you on the next one.